Hello friends, today in the new topic we will discuss about mass spectrometry. We will see here the introduction and instrumentation about mass spectrometry. I am Dr. P.R. Mahalle, Assistant Professor and Head, Department of Chemistry from late Bhaskara Singh Arts, Professor Narayan Rao Gawande Science and Ashalata Gawande Commerce College, Sakarkheda. So we will start our topic. We will see the introduction of mass spectrometry. From the last 50 years, the applications of mass spectrometry which have been applied to organic chemistry, and it can be used as a key tool to identify the molecules through their molecular weight as well as their isotopic abundance. The basic principle is quite simple, that is, the compound whose mass spectrum is to be determined is first converted into vapor form. Liquid samples are volatilized under vacuum in the heated reservoir and the vapor is leaked into the ionization chamber, where the pressure is kept very low at about 10 mm, and there it is bombarded with the electron beam of high energy, about 10 to 70 electron volt. What happens? By the electron bombardment, the ionization occurs and the positive ion is formed. This positive ion is called as molecular ion or radical cation or parent ion. The reaction can be very simply shown as that the neutral molecule by the electron bombardment can be converted into molecular ion. We will discuss about the instrumentation of the mass spectrometer. Here the sample of the molecule under analysis is sent into the ionization chamber. In the ionization chamber, the molecule is ionized through the ion source, and then the molecule get ionized and the parent ion is detected through the mass analyzer. This mass analyzer not only detects the parent ion but also it detects the fragment ions. These are passed, and again in the chamber the detection of the various fragment ions have been carried out. The next step of the instrumentation is the amplification of the ions. During amplification, simultaneously digitization of the ions which are formed in the vacuum chamber is analyzed, and then a simultaneous mass spectrum of the sample molecule we get digitally in the form of a graph. This mass spectrum is located as the relative abundance against the m by z values, that is the molecular ion and the fragment ions of the molecule. The mass spectrum of the typical compound can be shown as in the following graphical representation. Here the relative abundance in the form of percentage against the m by z values of the fragment ions which are formed during the ionization of the parent molecule is formed. Here we are getting two types of major peaks. One is the base peak, in which the relative abundance of the fragment ion is about 100%, and another is the molecular ion peak, in which we can get the percent that is the m by z value of the molecular ion, that is the actual weight of that particular molecule. So this is all about the mass spectrum and instrumentation of the mass spectrum of the typical compound. Hope you will get some idea clearly in the topic discussed in this video. We'll see further topics in the forthcoming videos. So thank you for watching this video, and I request you to subscribe this channel and if you like this, you can share to your friends.